Hi and welcome. I am going to I'm going to talk about basically chapter 7. I'm going to do 7.1 and then I'll come back and do another video for 7.2 in the book. I'm just going to give kind of an overview of how this works. This is what we call natural deduction. What we had been doing is we've been kind of using tools to evaluate whether or not arguments work. What we also do is we find with these same kind of statements that are, things like, if A, then B, A and B are true, that kind of thing, that we can use our reasoning in our head, we use it naturally, we perform the deductive process. But what we find is that we can use the rules, a set of rules, predominantly just a set of like 8 rules of inference and some rules of replacement and things where we basically say, this means the same thing. And we can basically work the logic in an argument like a math problem. Now, the people who are more analytic philosophers, they love this as a process of doing it. They do quite enjoy that. And so, that is something that's kind of interesting. So that is one thing to keep in mind. But as far as it goes, we do have, we do this with philosophers. We use this as our process of doing that. So I'm going to give you some examples. I'm going to give you the first four rules of replacement, and I'm going to just do a few problems from the book to kind of show you how this works. So as you go along, before I get started, if you have a textbook, and you may have gotten one that was bound, you may have gotten a loose leaf one, but usually with a bound one, and I don't know for sure, but a lot of times they'll put in here on the back page, they'll put the rules of replacement up here at the top. There's the 8 rules of replacement, and there's, the 10 rules of replacement at the bottom, 8 rules of inference at the top. And so you can actually find those rules in your textbook, kind of there, easily to find. I don't remember if I gave you a sheet for that. I don't think I did. But, if you want, you could always write those out. You could always make a copy of that, or you could find that in your book and make a copy. And it makes it just very convenient to have it all in one spot, to have all the rules there. But before we do that, let's just talk about it. So there were, I need to share my screen. And so I'm going to use the whiteboard here. So basically, there are 4 rules of reference. The first one is what we call modus ponens. I talked about this in the last one. And modus ponens is just, P horseshoe Q. P is true, therefore Q is true. It's just a simple idea that if the antecedent is true, the consequent, if we have a statement like P then Q, we know the antecedent is true, therefore we know the consequent is true. We usually abbreviate this just MP for modus ponens. And that will become of some value as we begin to do these. Next one is modus tollens, and this is where you have P horseshoe Q, we have tilde Q, and therefore tilde P, and we just abbreviate this MT. And basically all modus tollens does is it says if the consequence not true, the antecedent can't be true. The antecedent's not, or the consequence not true, the antecedent can't be true. We then have what we call, let me make sure I have the right ones, disjunctive syllogism. I went over these in 6.6, so in your last goal, you should have gotten a little rule on this. And then you get what's called hypothetical syllogism. And so disjunctive syllogism is just with a disjunction, P or Q, and you say not P. You could also say not Q. And then therefore P or Q, if it's not P, then Q has to be. If it's not Q, then P has to be true. And then hypothetical syllogism is saying, if you have a statement like P horseshoe Q, and then you have one like Q horseshoe R, then you know P horseshoe R has to work. If you take this middle term, and you basically can take the antecedent off the first one and the consequent off the second one and make it one statement. So if you have a term here where the consequent is the antecedent in another hypothetical statement, you can simply combine them, keeping the antecedent from the first one with the consequent from the second one. And this works because, if you were to say, if P horseshoe Q, so you say, if Paul's here, then Quinn will be here. And if Quinn's here, then Raul will be here. Therefore, Paul, basically saying, well, if Paul's here, Quinn's going to be here. And if Quinn's here, Raul is going to be here. it's without question that by domino effect, Raul will be here. So that's the way that works. Now, we're then going to take this information we've received, and we're going to use that in order to do basically some problems. We're going to follow the logic. And what happens is in order to save room, we begin to write these, where what we do is we start and we write our premises on their own lines. Each premise goes on its own line. So we start with like P horseshoe Q. Number 2, next premise is P. Then whatever the conclusion is, we put a couple lines here and we write it over here. Then what we do is we know P horseshoe Q P, that's our argument, and we're trying to prove Q. And so we take this is the setup, our first premise, our second premise, and we're going to see what can we deductively infer? What can we infer from that? Well, really the only thing you can infer from this is you can infer, well, you can make some other inferences, but we won't get to that yet. But what we can do is we can make some, some rules from this, but we know that Q is true. If you have the antecedent and you have the antecedent there, we know the consequent is true via what we call modus ponens. So what we do is we simply say, and that was using line 1 and 2, we created with modus ponens Q. And once you get a line that has the same thing as this, you're done. You have proven Q from this. And so what happens is all this entire chapter is doing is it's sort of taking these arguments and taking them from being something like, you have P horseshoe Q, P, therefore Q, and it's saying, how does this prove that? Well, we're going to just work it out on lines where we put the premises in here, the conclusion over here, and we're going to show you what rule of inference, what rule of replacement gets used by writing what gets inferred, and then what lines were used, and what operation was used. Now, with that said, what we have here is, this is usually with like the first unit, it becomes very easy because there isn't a whole lot that you can infer with these 4 rules. But you could have something like, if you had an argument like A horseshoe B, B horseshoe C, and then you had, tilde C, and you're trying to prove tilde A. Okay, so this is our argument. We're gonna write it like this. Well, this isn't gonna be able to be done in one step. But what you can do is you can look at it and say, well, what can I infer from this, from those 4 rules? We have modus tollens, modus ponens, hypothetical syllogism, and disjunctive syllogism. Well, we can infer from this, with lines 2 and 3, we can do a modus tollens, and we can get, tilde C, so we're negating the consequent, so that would negate the antecedent. And we can then take the fact that we've negated, we have a tilde B, we can use that with line 1 to get a tilde A. We can say, oh, well, if we use lines 1 and 4 and perform a modus tollens, then we can get bar A, or tilde A, which happens to match. So we've proven our point. But the other thing is you could also very easily say, well, what if I didn't solve it that way? Is that the only way to do it? No, that's not actually the only way to do it. There is another way to do it. And that is, you could actually have started off with line 4, you could have said, oh, but wait, this consequent is this antecedent. Why can't I just put these 2 together as A horseshoe 3, A horseshoe C via 1, 2 hypothetical syllogism. HS is how we abbreviate that. No, there's nothing to stop that. And then because you have tilde C here, which is the negation of C, you can simply get tilde A via 3, 4 modus tollens. And so this is all it's doing, is you're trying to follow it through. We know that if we were to write this A horseshoe B, B horseshoe C, tilde C, we know that proves tilde A, but we're asking the question of how do we get to that point? Hold on just a second, somebody is at my door. I need to go check that. So I'm gonna just hit pause here. Okay, I'm back. Sorry about that. I don't know how the pause worked there. It was UPS, so nobody actually at the door, which works out well for me. Anyway, So if you go to the back of the book with some of the homework, basically it's just going to start off and it's going to have like, very simply, it's going to start. And the reason I say look at the homework in the book or the exercises that are online is it kind of gives you a warm up for this. But you'll start off with something like, you know, number 1 in the book is, G horseshoe F, and then it's tilde F, and they're probably going to prove tilde G. Well, it doesn't actually tell you what they're trying to prove. Never mind. And then it just has a line here and a line here. It's saying, what can you infer from this? And the only thing you really can infer is tilde G, and you do that by a 1-2 modus tollens. And so all the first part is doing is asking you to look at it and see, what kind of things can I infer from this? So for example, you know, even if you get like number 11 in the book, even if you get like number 11 from that part of the book, which is, let's see, it's, is W wedge B W. Well, you can't do a disjunctive syllogism because you'd have to have tilde W to do that, or tilde B. So that gives you another one, and it's B horseshoe T. Well, you can't get anything from that. And then last one is W horseshoe A. And then it's saying, what can you draw? Is there anything you can draw out of that? Well, if you look, you've got an antecedent and antecedent. Therefore, you can draw A via lines 2 and 4. We're using line 2 and line 4, and we're doing a modus ponens. And that's all you're doing there. After that, in the next section, which is kind of, I mean, you know, if you do these problems, you should be really well prepared. But the next section, it'll do like number 1 on section 2 is B wedge K, and then it has a blank line, and it has kind of our conclusion is K via some unknown description. Well, what's the only way with B wedge K from those 4 rules we could get K out by itself? You'd have to negate B to do a disjunctive syllogism. And so you would simply write in tilde B in order to negate that and bring K down by itself. And you're doing 1-2 disjunctive syllogism. Okay, and then those go on for most of that chapter. And then finally, you get into kind of more lengthier problems where you actually do something more. Now, I want to do just 1 or 2 of these in section 3. And the reason is one thing to keep in mind is if you have something like number 1 here is tilde C horseshoe A horseshoe C, and then number 2 is tilde C, and our conclusion is tilde A. Now, the thing to keep in mind is the antecedent is the entire thing before, and the consequent is the entire thing after. So if you do this, the next one would be a modus ponens to get A horseshoe C via 1-2 modus ponens. You're taking this whole thing has to be here in order to give us this whole thing. You can't just bring down one part of this. You have to bring down everything after the horseshoe. Whatever, and the main operator has to be the horseshoe to do a modus ponens. If this had said just the letter C, you couldn't do a modus ponens. It has to be the entire thing, tilde C. And so then you can bring down A horseshoe C. You still have tilde C here. You can use that premise again to get tilde A via 2-3 modus tollens. And we now match. So we can do another one of these. Let's do another one of these, maybe a little bit longer one, kind of crazy one. Let's do number 19. I have not pre-read these, but I have, you know, taught logic a few times. So I should be able to handle this on the fly and not embarrass myself too much. So we have tilde A. I had another textbook that would use, instead of tilde, it used a bar, and so sometimes I still use that as a throwback because I used that book for 5 years or so. So anyway, and then it has brackets A, wedge, T horseshoe R, close brackets. Next one is tilde R horseshoe, R wedge, A horseshoe R, Next one is T wedge D horseshoe tilde R. And then we have T wedge D, and we're trying to prove just D is true. All right, how are we going to do that? Well, first thing we're going to do is we can look at this and say, hey, we can do a modus ponens. That antecedent right there is right there on line 4. So we can do 3, 4 modus ponens fairly quickly to get us tilde R, right? Yeah, I would think that would work. I'm sorry, that's line 5, sorry. I don't know why I put 2. So we can then use that as the antecedent here, tilde R. So we could just very easily get number 6, which would be, you know, R. We have to take, this is the antecedent. So we have to take the entire consequent, everything in brackets, R wedge A horseshoe R, parentheses, which, wish I'd left myself a little more room. I'm just going to erase this right here and move it over just so I have a little bit more room over here. What was that, D? So we now have tilde R, which is the negation of this disjunct, right? So we could just do via number 7, we could do, I'm just going to come up here, we could do A horseshoe R via 5 and 6. My face was in front of that. I don't know if it was showing up there for you. Disjunctive syllogism. So we now have that, ds, 5, 6 ds. So we've done the negation of this because it's there in 5 to give us the other disjunct, which is A horseshoe R, which then very easily allows us to do a modus tollens with the tilde R. We have it up here in line 5. And line 7, we can do a modus tollens. So we're negating the consequent from number 5, negating the consequent, which will negate the antecedent. That allows us now to do a modus ponens on lines 1 and 8, which allows us to get A wedge, parentheses, T horseshoe R. Once again, you have to make sure you take the whole thing. Let me just rewrite that. A wedge, T horseshoe R, parentheses, and that's 1, 8 modus ponens. We now have the negation of that up here in 8, so we can do 8, 9 ds. So we can get T horseshoe R, and we now have T horseshoe R, and I'm trying to think what we can do. Oh, we got the negation of the consequent in that, so we can get the negation of the consequent here with 5 and 10, and that's a modus tollens to get us tilde T. And once we can negate T and prove T isn't true, we can prove that D is true via a disjunctive syllogism between lines 4 and 11. Now the thing is you can use any line before this, that's fine. You can't use the part after this line. This is just showing you what you need to prove. This isn't part of it, it isn't anything. You have to use the entire line, you can't break it up, but that's the way it works. And you can take a very difficult argument, like if I say, if Alvin's not here, then it's the case that either Alvin is here or T horseshoe R, or Terrence is here, then Regina is here, or something like that. And if Regina is not here, then it's either the case that if Regina is here or if Alvin is here, then Regina is here. And you know, essentially what you find is that if this is true, if this part is true, you're going to force this part to be true, which is going to force this part to be true. And same thing here. And interestingly, you're going to prove that that's not true in the process. You're going to prove that's not true in the process. And really that's all you need is in order to prove this. But you needed all that other stuff in order to have this very long example of how to do it. These can get very long and you can have a lot of stuff there, but they, you know, I mean, I find them to be kind of interesting and fun. They're kind of like doing maybe a Sudoku or something like that, but not nearly as popular and maybe a little bit more annoying at times. But that's the way it works. So I'm going to go ahead and end this, and I'll go on to 7.2 in a different video.